Thank you, Chris. 3 years. It has been 3 years since I have stood in front of a group of people. So I really, really appreciate the opportunity. Thank you very much for letting me. And there has been something I have been waiting to do for 3 whole years. So let me just take my shoes off. All right, we're ready to roll. Okay, so I want to talk. This is not a Lord of the Rings talk, okay? I'm sorry. But I do want to talk about some thinking I've been doing actually over the last 3 years about all the mess that we've got ourselves into in software development. And it kind of started back in, when was it, 2015? Something like that, in Amsterdam, where I gave a talk called Agile is Dead, which started the hate mail. And that talk came about because I was really frustrated by the state of the Agile industrial complex, really. How Agile had lost its way. It had become a really big commercial consultancy machine. And so I wanted to bring it back to its roots. And one of the things I did was try to actually isolate the essence of what I thought agility was. And for me, it comes down to something very, very simple. Agility basically means you want to find out where you are, find out where you want to go, take a small step, and then use feedback to adjust. And you do that at every single level, from the naming of variables to the overall intent behind your project. And to be honest with you, I can't remember, and I should really go back and look at it again, but it's just too embarrassing. I can't remember if I had this next step, because on its own, that doesn't really hack it. There's one more thing that you have to do. And so I introduced this how phase a bit later on that says that when you're faced with 2 or more alternatives, choose the one that makes future change easier. Kind of sounds like common sense to me. This caused a lot of fuss, though. And I'm going to go through why I say this and what the fuss is. And then recently, I've come to realize how you can actually overcome the fuss and reach the nirvana that this slide represents. So a lot of this talk is actually motivated by this one paragraph here. So let's step back a little bit and work out how we got to the manifesto and then how we got to the state that we're in today. We have been writing software in the kind of form you'd recognize today for probably about 70 years. And throughout that time, we've been really, really concerned about getting our software correct, writing programs that will produce the correct output. And we have found many different ways of trying to do that. The classic, okay, if you're a consultant, you have to bring out a waterfall slide at some point, and you normally bring out the incorrect waterfall slide, which is this one. This is not the slide, this is not the diagram that Royce drew. His has feedback and all sorts of stuff in it, but that doesn't really play well if you're trying to diss it. So instead you give it the wrong slide, and you show this waterfall of you do this, and then when I'm finished, you do this, then you do this, then you do that. And then you get to delivery, and there's an implicit step in every waterfall diagram, which is, we'll try and do it better next time. So this is waterfall, been around 30, 40, 50 years, I have no idea. Of course, people have adopted it over time, or adapted it, over time. So we currently have an agile version of this. It's called SAFe, but it's fundamentally the same thing. SAFe is really cool, though. It's designed to appeal to the sort of child in everyone. So we have runways and trains and streams and bicycle paths and zip lines and all of these kind of cool concepts in SAFe to make it sound like it's fun and we're always going to make progress. But fundamentally, it's this. Other people have looked at things to make our code correct. Type systems. People think, okay, if I can give the type of everything, then my data is always going to be correct. Well, obviously that's not quite enough, so we have to add higher order type systems to make it even more complicated to make our code correct. One area we have had success is in theorem proving. Back when I was at college, a lot of work was being done on how do you prove code is correct mathematically. And you could do preconditions, postconditions, loop invariants, all this kind of cool stuff. It just turned to be totally impractical to do it in the real world, unless you were in a constrained domain. And people who are doing hardware design languages are actually doing proof that their designs, for example, have no race conditions. And so this is actually a viable way of showing certain programs are correct. And then we get to the crowning achievement of the last 10 or so years, and that is 100% test coverage, which I personally think is ridiculous, but that's what people like to say they've got. So we have all of these ideas that lead us towards this idea of correct code. Now, the idea of correctness and knowing that things are correct goes back way, way beyond before code. It probably goes back to when we first rubbed two sticks together. But a quote I quite like comes from Laplace, the mathematician. I'm going to read this just because. We may regard the present state of the universe as the effect of its past and the causes of its future. An intellect which at a certain moment would know all the forces that set nature in motion and all the positions of all the items of which nature is composed, if this intellect was also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest of the bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain, and the future, just like the past, would be present before its eyes. That's the basis of a whole bunch of the thinking behind software development. If we know everything, then we can just code to it and everything will be correct. Now, clearly, that's a load of bullshit. I mean, it can't work. If nothing else, Heisenberg told us that we can't know the position and momentum of any two things at total accuracy. And Gödel told us that no system can actually correctly validate itself. So we know that this idea of knowing everything means that we can actually do everything. It's just not going to work. So instead, we need to rethink what we mean by correct. Rather than thinking about our code as being correct, we need to think about our code as a way of dealing with uncertainty. So let me hit you with Thomas's postulate number 1. In all but the most trivial of cases, there is no such thing as perfect code. There is no such thing as correct code. I'm sorry if that causes offense, but I have certainly never come across any decent-sized chunk of code that I would say is correct. It may do what people originally wanted it to do, but I would still say it's not correct. Because in order to be correct, you have to deal with change. You have to deal with the fact that the universe is not static. Our world is not static. The world in which our code lives is not static. Now, this change that we live with, I don't know if you've noticed, but it's accelerating. It's accelerating to the point where the half-life of knowledge is, well, there's two aspects of that, but requirements used to change at the rate of about 20% per annum. And it's feeling to me that that's dropping down to about every 20% every maybe 2 months at the moment. Now, where do these changes come from? Well, there are external changes. So we have change imposed on us from the outside world, changes in policy, in law, markets. Various strategies may change inside our companies to deal with changes in the environment. Resources may change, and that would force a change on us. People change, and people's expectations change. Our understanding, this is a big one, our understanding changes, and that forces us to rethink the way we've done things. This is kind of like consensus change that we're also falling victim to at the moment, that's driving us to do things. And lastly, but by no means least, nature is changing, the world is changing, and that's forcing us to adapt as well. These are all external drivers of change. There are also internal drivers of change, things that come from our own companies, our own organizations, from ourselves. We have new products, features, and integrations that we have to deal with. We're doing testing, and that's telling us how to drive our code going forward, different kinds of workflows that we're going to do, regulations, site layouts, bugs, and of course, the biggest single change or biggest single destructive change in the software industry, Elon Musk. So all of these things are forcing us to deal with the idea of change. I used to give a talk on why perfection is bad. And it ties into this idea. Because if something is perfect, you can't change it. Because any change you make to something that's perfect will mean it's no longer perfect. Whereas everything else will change. And just to make this kind of scientific, there's a Venn diagram, and you can see that there's no overlap, right? I mean, you have everything that's perfected, and then everything else. Except, just like black holes that evaporate through Hawking radiation, perfection actually also evaporates through reality evaporation, and so perfection disappears. So all we're left with is everything else. And technically, we call that everything. Right? Nothing is perfect. Everything has flaws, everything changes, everything is going to have to be dealt with by our code. So I come back to this idea that we should not be valuing correctness as the most important thing our code should do. I think that the ability to change our code is more important than the ability to write correct code. Because code that is hard to change will never be correct. Code that's incorrect, but you can change, stands a fighting chance. So I think that when we're writing our code, we need to be thinking about being mostly correct today, as correct as we can make it. But we also have to make sure that we understand that we will update it tomorrow. And so our job as developers, I think, is to create things now that we can change, so that they will survive long enough to be changed and updated tomorrow. Now, that's kind of abstract, and to be honest, it's kind of what we are doing anyway. But all I want to do here is to make this explicit, because towards the end, I want to show you how we can actually formalize this a little bit and make it easier on ourselves to do this. So let me start with a pretty obvious example of how as developers, we deal with the need to change right now. So maybe I'm writing some code, some kind of online salesy kind of system, and I need to calculate tax, GST. So I know that GST is 10%, has been since it started, so I'm going to code up price equals price times 0.1 to get my tax. And then in some different module, I'll have the same calculation, because why not? And then maybe I'll have a separate one that actually pays the tax, and obviously it's going to have a calculation as well. And everybody in the room was going to say, oh, Dave, that's ridiculous, right? Magic numbers. No one should use magic numbers. That's kind of like the first thing you're taught as a developer. Don't use magic numbers. Why? Because the number might change. So we're taught replace magic numbers with constants. So instead, we might see code that looks like that. And at this point, we might be happy. Now, in the real world, okay, this is where I'm just like relying on Wikipedia, but to my knowledge, GST was introduced almost 23 years ago. The rate was 10% back then. The rate is 10% today. They are talking about increasing it to 12.5 or 15, but right now it's still 10%. So that first line of code would have worked. There was no need to make that change to add the constant, except I lost track trying to count the number of changes they have made to how you apply GST. Right? Does it apply to this? Does it apply to that? Are there various goods that are exempt? Blah, blah, blah. So you're better off, I think, abstracting out one extra step and saying, okay, so my GST, I'm going to have a formula that's going to, a function that's going to calculate it, rather than just doing it in line. Okay? Again, really obvious, everybody would do this. So this is just common sense. And just given that I like to package up common sense and charge people for it, I called this dry. Don't repeat yourself. But what we've really done here is given ourselves a single place where we can specify and change some information that we have. And this makes it a lot easier to change, in this case, both the rate and the rules. So let's keep digging into change. The rules are going to change. So we're going to split our tax calculation out into some code that actually has, some add GST as our function, and probably we want to have some data structure that describes how we're going to apply it. What are the rules? What are the exceptions? All this kind of thing. But I wouldn't want to have that data structure in code. I would want to have it somewhere that I could change it more easily. Maybe a database or something like that. But if I did that, how am I going to change it? I don't want to be a programmer that does those changes. So instead, I would like to give my customers, my users, the ability to make that change. Again, we want to make change easy. So the last thing I want to do is to write code. So often when I'm faced with this kind of situation, I'll set them up with a spreadsheet and then have some macro that exports CSV into my system so I can then update the tables and do whatever I have to do. And we can run with that for a while, see if it works, if people like it, and if they feel the need, then we can switch into a UI. Again, we're looking to make it easy to change. Now we're going to start applying some more design principles. So we want to create a sales module. So we're going to apply the single responsibility principle. And if we do that, we're probably going to split it out into its own like sub-service or something else. And then we're going to look at our tax calculator and say, well, actually, there's two components here. We have a tax calculator, and we have the rules maintenance. So we'll split those out as well. So all we're doing here is we're applying all of these good principles that we learn when we come to conferences like this, all the various design principles. So we may be learning dry or SRP or whatever the buzzword du jour is, right? All of these are very solid principles that make our code better. There's another side to this. It's not just a question of how we design the code, it's how we write it as well. And over the years, we've come up with cool ways of writing software. So now, if you're not using version control, well, you're an idiot. Automated testing, short iterations, very good. Pair programming, great if you can get away with it, etc., etc. Now let's think about that. Let's think about all of those things we've just looked at. The design principles and the actual coding experience. I would postulate that every single one of those things is simply an implementation, a special case of make your code easier to change. If you use dry, then you give yourself a single place to change a particular representation of some knowledge. If you use source control, then you make it easier to roll back if a change you've made to the code is a mistake. If you have automated tests in place, then you give yourself the ability to test for regressions when you do make changes. If you have pairing in place, then you're spreading the knowledge, again, making it easier to make changes. So I assert that a lot of what we do, the practices that we follow, both design and also the actual practical side of it, are all to do with making our code easy to change. So let's come back to this. I would say that the ability to change our code is just baked into that. The whole point of being agile is being rapid, easy to change, having the ability rapidly to change things. So I would say that that is just one more example, right? You can say the entire agile movement, or in its pure form, the entire agile movement, is just an instantiation of let's make it easier to change the thing we're producing. So let's focus back in on this particular side. And this is where I got into trouble. Because I said, when faced with two or more alternatives, take the path that makes future change easier. And right out the gate, people said, how do you know? How do you know, A, what paths are available? And then how do you know what's going to happen in the future so you know which one is going to be easier to change? And to be honest, my answer was kind of like, well, it's kind of obvious, which is what consultants say when they don't know. I didn't know. And I've been worrying about that since somebody asked me that question. Because I feel that when I code, I do that, or at least I try to do that, and I'm relatively successful at doing it. I feel that, when I make changes, they're relatively straightforward a lot of the time. Probably better than if I was just making random decisions. So I decided to try and work out how I did this. And I came to a really unfortunate conclusion. And that is, I do it, but I don't know how I do it. I do it using intuition. At which point you may well groan. Thank you. I swear audiences must have been better before COVID. So I do it using intuition, and I don't know if you've been in one of my talks when I've done this, but if you have, humor me. If not, participate, right? And here's the proof, because people say there is no room for intuition in software development, right? It's like there's no crying in baseball. There's no intuition. We're a science. We do things, pragmatically. There's no intuition. So, you're a programmer. You start work one day, and there's a bug. And you work all morning trying to sort this bug out. You can't find it. You take a quick lunch, come back, you're still working at it. You're trying more and more ridiculous things to fix it, constantly reverting back because you destroyed half the source code trying to find this one bug. You work an extra hour in the evening to try and find it. You cannot find that bug. You go home, you are miserable to be with because a large part of your brain is still sitting there stewing over this bug that you cannot find. You go to bed. Can you go to sleep? No, you're kind of tossing and turning, thinking about this bug. Eventually, you fall asleep. The next morning, the alarm clock goes off, and you wake up, and you know exactly what was wrong. Hands up, how many people has something like that happened to? If that's not everybody, I'm surprised. Intuition is how we write software. Everything we do is intuition. Intuition is the most important aspect of our brain. Intuition is how your subconscious contacts your consciousness. Now, what do I mean by that? Well, I think I have no qualifications in this whatsoever, which is why I get to stand up in front of you and tell you all about it. So, your brain has many layers to it, but you have definitely as well as your kind of like the automatic side of your brain, you have a subconscious and a conscious, or whatever you want to call the subconscious layer. And that subconscious layer is actually the most powerful part of your brain, because it is the part that from birth, probably before birth, is constantly looking at patterns and forming associations. And as far as I'm concerned, that's pretty much all it does. If you look at a 3-month-old, they are moving their limbs in apparent random motion, but it's not random. They're learning that, oh, look, if I do this, my hand does that. If I do this, my hand does that. They're not learning it consciously. They're learning it inside their subconscious. They're making these associations. We learn language. We could not possibly speak language if we were sitting there thinking about every single word that we had to produce next. When you're first learning a language, that's kind of what you have to do. But the whole point is to drive it down, to make it an instinct, to make it an intuition, to know, you just know what word follows. This is crucially important. I was going to throw a water bottle at someone, and I thought, no, there's probably laws against that. But imagine I threw something towards you, not viciously. I just lob it gently towards you, and you catch it. And then I say, okay, how did you do that? Because the laws of motion govern that water bottle. At the simplest case is a nice differential equation. And then the laws of motion that, your hand moving up to the right place, and then your fingers and your orientation, and when you close them, well, that's a pretty complex nonlinear system. How do you do that? Describe to me each individual step you take. You can't do it. Because you've learned how to catch a ball by missing a ball hundreds of times as a kid. And then eventually, something kind of clicks, and you get better and better at it. Same with driving. I don't know about you, but I quite often get to the shops without actually remembering driving there. I'll have been thinking about something else and driving quite happily, and I only become conscious of the driving, when something weird happens. Intuition is how we run our entire lives. So it really does pay us to feed our intuition. to feed our subconscious. And there is a well-known, well-researched way of doing that. We call it experience. And there are two parts to experience. First of all, the obvious part is you've got to do stuff. Right? If you don't know how to catch a ball, someone's going to have to throw a ball at you, and you're going to have to experience having a ball thrown at you. Okay, pretty straightforward. The second and crucial part is that we have to observe the result. And we use that result to train our subconsciousness. If this strikes you as being very similar to how modern AI works, it's not a coincidence. Back when I were a lad, a book came out called The Inner Game of Tennis. And the BBC ran a documentary on the guy who did this and his techniques. And I don't know what I was, 12, 14 or something when I saw this. And it made an impact on me that it still stays with me today. He was teaching, well, first of all, his premise is that there are two parts to being good at sport. There's the physical part, but there's a mental part. And his focus was on how do we get the mental part up to the level of the physical part. And so in this documentary, there was a picture of him helping a woman to serve. And so what he did was he set up a chair on one side of the net. Then he brought out a laundry basket full of tennis balls and put it on the other side of the net. And then he said, I want you to pick up a ball and serve it across the net. But I do not want you to aim at the chair. Instead, I want you to verbalize where the ball lands in relation to the chair. Left, right, in front of, behind. And do that for, I don't know how many balls there were in the basket, 100, 200, whatever it was, right? And just really, honestly, do not aim at the chair. Just hit the ball and say where it is in relation to the chair. And so, we saw the woman hit the first 2 or 3 balls, and then we had one of those little time-lapsey things, and then the basket got lower and lower. We got down to like 20 balls left, and he said, okay, now hit the chair. And she hit it every single time. Because those 180 misses had trained her subconscious into the motion and the movements and the impacts of those. But it did it because she called out the error. And she verbalized the error. And it turns out there's a really important part of that. If you simply think to yourself, oh, hell, I missed to the right, it doesn't work as well. Because when you verbalize something, what you do is you're taking it outside your brain and then bringing it back in again. And that strengthens the reinforcement. For some reason, I don't know why. So, here is my suggestion for how you build the intuition to let you do my second paragraph there, which is select the path that makes it easier to change. And I've been thinking about this for a while. I've been doing this for a short while because I've really only crystallized it fairly recently. And it has really helped. It's going to seem a bit stupid in the same way that hitting a tennis ball at a chair and deliberately missing seems a bit stupid. But try it. Print off paper that has headings on it, or even be radical and just use blank paper and write the headings. And before you start making a change to your code, just make a 1-sentence summary of the change that you're going to make. And while you're at it, kind of guesstimate the impact You can guess time, you can guess number of modules, number of bugs, whatever you want to do. Some estimate that is important to you of how expensive that change was. All right? So you make a note, those two things. Then, when you've finished and you've done your commit, or commits, two more headings. Actual effort. So just go back and look at what you said it was going to take, and then actually write down what it did take. And then, if you want to, write some observations. So here's the key. Do not think, oh, I'm going to go, create a React app for this or something. Don't. It is really important that you actually write this. Right? The more modalities you can bring, the more reinforcement you're giving your subconscious. So ideally, if you don't mind getting looked at by other people in your office, read it aloud as well. Having written it all out, stick the paper into a file in your desk drawer and forget about it. Don't throw it away, because then you're kind of saying, oh, it's not important. Stick it in a file, but that's it. You don't have to do anything else. And then the last thing, and this is the hardest thing, is to start trusting your intuition when it comes to this kind of thing. And start trusting it from day one. And what you will find happening, at least what I have found happening, and if it happens for me, then it must happen for everybody else, right? But if you try this, I pretty much guarantee that you will then be in the position to say to people, well, it's obvious. This change is better than that. Sorry, this way of doing things is going to be easier to change than this way of doing things. And people will say, well, why? And you'll give the only answer you can give when you rely on your intuition, which is, well, because. Yeah? That's, by the way, the mark of a really good consultant. A really good consultant, an expert, is someone who's worked out how to lie and make excuses for what their intuition tells them is the right way to do something. Right? Because in reality, they know within 10 seconds the way to do it, but then they had to spend 2 hours coming up with some white paper that justifies it. So, I promised you one rule to rule them all, and that's it. Make it easier to change. That's really all there is to it. Ha ha. But I'm serious. If you start learning to rely on your gut, you will find that this actually becomes a viable process that will make your code better, more flexible, more agile. And obviously, we need an acronym, so easier to change becomes ETC, which is why I had ETC at the bottom of just about every single one of the lists on my slides. Subliminal, huh? Right? And that's really all I've got to say. Right? Make your code easier to change by relying on your gut and train your instincts so that that works. And then finally, there's one overarching rule, always in every single one of my talks, and that is, remember to make it fun too. Thank you.
Thank you, Dave. Questions from the audience?
Thanks for the talk, Dave. I'm thinking about the appliance of this rule when it comes to choosing like third-party modules or systems where when we choose something like that, automatically with experience, we feel that it's harder to change, but sometimes it's the choice we have to make. What are your thoughts on that?
Okay, I'm not 100% sure where you're coming from in that, but I'll tell you my philosophy for that, and that is desperately try not to use third-party modules, right? If you look at the average application nowadays, I don't care if it's Ruby, Elixir, JavaScript, all right, you're looking at hundreds, if not thousands, of dependencies. And fundamentally, what you have done then is you have built a carbonite straitjacket for your application. Because every single one of those dependencies represents an interface that you have no control over. You cannot change. And typically, I see developers using a third-party library to do some really, really trivial thing. Right? They may be using one function out of it, and that function may be doing something as stupid as, I don't know, converting a number. That's a bad example, but something at the logical level of converting a string into a number or something, right? So one of the key things, I think, to make your software easier to change is to cut out dependencies if you can. And I've been kind of experimenting with that a little bit recently. I've been doing a fair amount of work with parsing. And I started out using third-party parser generators and parser libraries and this kind of stuff. And almost without exception, I find I found areas in them which make it really hard for me to either change my code or do things I want to do, like report decent error messages or things like that. So gradually, I've been falling back into doing a lot of that work myself in my code. And to my surprise, my code actually is no longer. There's not much more code. I throw the library away, just write the code myself. I'll use like a string scanner and recursive descent. And the code is cleaner, easier to read, and I get control over it without having a third-party dependency. So for me, that's a win in so many ways, but being able to change that code is the biggest win for me. So I guess the underall answer is get rid of all your dependencies. Right? Write Rails from scratch. Or even, no, I'm not going to go there.
You heard it here, build before buy, always. Other questions?
Thank you for the talk. A question, make it easier to change, let's say, relies a lot on experience, building your intuition that comes with many, many years. So from a management perspective, if you try to bring some of those concepts to your team where you have more junior type of people, how would you, from a management perspective, try to carry that message to a team of younger professionals?
Oh, okay. So from a management perspective or from a team perspective? Let's do both, all right? So from a management perspective, okay, I am probably the worst person to talk about management because I typically try really hard not to be managed, and therefore, I don't really have that much experience. However, one thing I have noticed is that the best managers out there are the ones that model their beliefs and don't impose them. And in this case, modeling the learning that drives intuition fundamentally means admitting to mistakes, verbalizing those mistakes, and accepting that I've just learned something. It's not a big deal, right? Now, as a manager, your mistakes tend to be amplified a little bit. So what does that mean? That drives you into making smaller and smaller decisions, which is a better thing, a better place to be in anyway. So I would say, from a manager's point of view, just model this. Do it out loud, right? Because it will help build you up as a manager, but also demonstrate to your team that this is an acceptable thing to do. The team can do exactly the same thing. So if you're pairing with a more junior person, right, I personally find that to be one of the more exciting things I do, because I'm constantly typing away and they'll say, why did you do that? And you'll go, it's obvious, and then you'll have to stop and think, And two things happen there. Either you try and trawl back through your memories to work out why you think it's the right way to do it, or you suddenly realize that you're doing it simply because that's the way you've always done it. And asking the question has forced you to go back and think, is that actually a good way of doing it, right? Even if you can't come to a yes/no answer on that, do it a different way. Write down this little sheet of paper to say, hey, I tried doing it a different way. Tell your pair that you're trying it a different way. You verbalized it, right? You got it out there. And then, hopefully 15 minutes later, when you look at the result, you can say, that was really dumb, wasn't it? And the both of you go, yeah, and you've both learned something. That's what I'd try, right? You don't have to be perfect. In fact, you're not going to be perfect. So revel in your imperfections. I know I do.
Thanks for the talk. Question on the correctness of the code. So you said that code is like never correct, as I understand.
Yeah.
But doesn't it depend on the actual domain where code is applicable? Because in physics, like if you're automating something in physics, probably code will remain correct for at least 10, 20, 50 years sometimes, just by looking from how we came from Newton model to relativistic model and quantum model. It takes much longer periods of time than legislation change, for instance, every half a year.
Maybe. I think there's many types of correctness. There's algorithmic correctness. There's also implementation correctness. So in physics, for example, although the underlying rules may not have changed, the orders of magnitude of numbers that you're dealing with may well. And a Fortran program that's using 4-byte integers may suddenly fall flat on its face, when it starts dealing with stuff from the Webb Space Telescope, for example. I don't know. But I would still assert that relying on the correctness of that code is not a clever thing to do. It worries me a lot. I did a fair amount of work, not a fair amount, I did 6 months or so, with people that were working at a government facility that was doing high-velocity wind tunnel work. And these guys were writing Fortran code that was designing things like hypervelocity parachutes and stuff like that. And the Fortran code they were writing was, frankly, 10,000-line functions that were absolutely, totally unintelligible. Now, I'm not labeling every scientist, every engineer with that brush, but I am definitely saying that that particular code was, if it worked, don't touch it, because nobody knows actually how it works, why it works. It's just an act of God. And in that case, I am prepared to lay odds that there were boundary conditions where it didn't work, and they learned over time to avoid those when they were doing their simulations. I don't know. Yes, there are definitely areas where the code is more correct or more likely to be correct. And those tend to be the cases where we typically don't work as developers, where the requirements never change, where the environment never changes, where the developers never change, the language never changes, the operating system never changes. There are environments like that, medical devices, but they are rare. So I think I'm allowed my hyperbole in saying all code is incorrect. Yeah, there are boundary conditions, but not many.
Time for one last question.
Hi, Dave.
Hi.
Thanks for the talk. One question. I think you've probably got everyone on board in the room around with the concept of making things easy to change. Curious if you have any thoughts or suggestions on how to take that same way of thinking and promote it to non-technical people in the business, say.
I don't know if that's going to take much promotion. Well, no, that's not true. It is going to take promotion, you're right. I think partly that's our fault. In the past, we have said to people, tell us what you want and we'll build it, which we could never really deliver, but we tried. But if I was okay, in my experience, and it's like 15, 20 years worth of like talking to people in various levels of companies about agility. In my experience, the senior managers are desperate for the idea, to have something they can change easily. Because they live at that pointy end where things are changing all the time, right? And they need to be able to adapt. Down in the trenches, we know that things change all the time. And the thing that's tricky is that middle level of, insecure management who feels that they're being constrained on the top, constrained on the bottom, and their only response is to dictate what has to get done, right? And those are people, not always, obviously, but who can be more resistant to this idea of rocking and rolling. These are the people who are resistant to implementing Agile, you know, because for them, this is a threat. I don't actually know. I mean, people say, how do I get my company to adopt Agile? And the answer is you don't. But the answer is you do it yourself anyway. Because if you do it yourself and if you model it, then at some point someone's going to say, how are you doing that? Why is that working so much better? Why is your team more able to change code than this team? And maybe they'll listen when you tell them. Yeah? I don't think you're going to force anybody into thinking about agility, thinking about change, thinking about changing their ways of doing things. Right? It's just human nature. But I think you can model it and just hope people pick up on it. Sorry, it's not a great answer, but it's really the best I've come up with.
Thank you, everyone. Please join me in thanking Dave Thomas.